Yeah.
All right. Welcome to a review for our celebration of learning. So there were a couple questions earlier via email and stuff, and also during office hours. And if I forget to address one, please somebody speak up, because I really do want to. I kind of put everybody off and said, can you remind me during class? And everybody's so shy and they don't want to, but it's that other people have that question also. It's that you thing that I just mentioned. Tinkerbell's wings got all twisted around, but Katie asked me, like, is there going to be more extra credit? You guys have had a lot of extra credits, and during the class, a couple of you have been playing, like Shaylee's like been answering questions more because she's figured out this game. You dress up on the celebration of learning, because if you dress up or paint your face to do with something we're doing, which is a lot, you have a lot of options. So we got all the water stuff, liquids. So she's got her waves going. You got the cat eye on. You can dress up as a cat. We got gas laws. You can dress up as a butterfly, a fairy, whatever. That's why I just Tinkerbell today. So you can do that. That's a bonus for your celebration, and it should hopefully make you feel calmer as you're taking your celebration and make you happy and make me smile when I see you on there. With that, it's going to be a similar format as last time. It's going to be all show your work. It will show up at 6 o'clock. It will be due at 8 o'clock. If it's in after 8 o'clock, you are going to lose points, because you all should know how to scan now. That limited time, and yeah, you can use your notes and stuff. You only have to come on if you have questions. Now with that, there was something that happened last time, and that happened in my other class too, and it happens when we're live also. Nobody comes and asks me questions until like the last 4 minutes, and I'm like sitting there thinking, I can't really help you at this point because you got to turn it in. Now realize this is the same celebration, similar, that I would have done in class, where they're there in class doing it, and they would have had an hour. You guys are given twice as much time, because I know there's distractions and things, but that also gives you the time. If you do have a printer, that's great. If you have to write it out, you do not have to write the question out. You just have to do it in the same order. So there will be, like, this format, as a question somebody asked me on the last one, it will be similar format as last time. I don't know how long it's going to be. It will probably be more than 3 pages, because I will give you more space. And I think this is almost longer, because especially with the gas laws, I gave quite a bit of practice, because I do know, like what happened today, that's the worksheet is a tough worksheet because it gives you practice. There is not, and this is possibly what Katie was asking me, there is not going to be an extra credit for you to do, but there is extra credit hidden in those labs. So I did want to mention this. This is a question somebody else had emailed me, and then I think Bea had asked, the lab 6A, which is the gas lab, you all hopefully have started on that. There's 6 choices. You just have to pick 2 of them. And if you're done by Saturday and can submit it Saturday, that's great. Or Sunday. You do have till Monday, because several people didn't realize there were 7-day challenges, and so I mentioned it Monday. And then a question Olga asked me at the end of class on Monday, she said, can I do 2 of the 7-day challenges? Yeah, you can pick 2 of the 7-day challenges. You can pick none of the 7-day challenges and do 2 of the other things. The question Katie asked me is if the art one, she said, like, she's an artist. Absolutely. Some people play music. I had somebody, some of the people do music. You can record a video and you can upload it as a private on YouTube, and then you just send me the link. It's like right there, and nobody will ever see it except me. And so some of them brought me to tears, because they were just, the one girl, she dressed up. It was just so cool. And that it was, and she played the ukulele, and I had no idea. It was a student who'd been with me for 3 terms, and so she was with me in the summer, and I said she had to do it again, and she did for another one of the challenges. Anyway, it's meant for you to have fun. The 7-day challenge, even if you did start Saturday, if you decide to do the meditation or the giggles and jiggles, I don't even remember what the challenges were. I actually recommend you continue through Monday, because if you keep giggling and jiggling through Monday with your celebration, there is a reason that challenge was put there before the celebration to help you. There's another one that's going to show up at Thanksgiving that will go be another 7-day challenge that you'll get to choose through. And we'll worry about that when Thanksgiving comes around. But anyway, it's meant to have joy and to have fun. Question that Katie asked about it, if you do one of the 7-day challenges, you do have to write like a paragraph or two about what you did, how it went. It's probably going to be a page, and how you did it. Yeah, and have fun with it. So, and all right, the other lab is, I called it lab 6B, so because they're both this week. I forgot to put the video up, and so it is there now. I did put it up when I got done with the mushroom picking today. And so Bia, thank you for asking me that earlier. That's why I asked you, go look now, because I knew what you were getting at, and I wanted to make sure it was there, because sometimes I put it in the wrong list or something, but I had forgotten to put it up. It's about solids, and I wanted to do something about solids because we talked about liquids, we talked about gases, and so I thought we should do something about solids. And somebody in my other class noted, I comment on it on the video, that I've been writing affirmations behind us. Today I put one about gases, or air. It's the air element. So you're gonna have that question shows up on the lab. You have to write an affirmation. It's part of the lab. And it's not just like, I'm gonna do good in the class. I mean, you can write that. That's not really an affirmation. First of all, it's not about you individually. It's about all of you. So you're gonna hear a story now. I had a student, and he actually got in the dental hygiene program, not waitlisted, he got in. And it's not because he was a boy. He wasn't a 4.0 student. He was a really good student. He blew me away with the affirmations, because everybody else would write about themselves. My cat loves me, or I'm having a good hair day, or I'm going to do good on this test, or something about themselves. He always wrote, we're all going to do great. We're all going to ace this. He always wrote about everybody. He didn't even know anybody in the class, because it was a pretty big class, and it just blew me away. And then I finally told the class that he was doing this, and not everybody switched, but like half the class switched. But anyway, yeah, be expansive. You can think about one of the elements, so gas, liquid, or solid, and think about that. Do you want to be grounded, right? So you can talk about being grounded, or we are all grounded and stable, right? That's really what solids are about, the earth element, and being stable and solid and grounded. You know, everything is connected. The roots of every plant on this planet, they're connected underground, which is really cool. You can be expansive, you can be flowing, but have fun with that affirmation. The other reason I did solids, it actually has to do a lot with the IMFs. And so it does, the 15-minute video, there's a chart you fill out. And so I walk through how to fill out the top half of the chart, and then there's unknowns. And the gnomes did the experiment, and you have to figure out what they must have, and what they might need to still do. And then the second side, you get to make a non-Newtonian fluid. And if you don't know what it is, I tell you to Google. And if you have children, you're all gonna let your inner child out, and you'll take a picture of yourself doing it. And then there's some post-lab questions, and some of you can do a drawing again. So have fun with it. But it is meant to help you with the intermolecular forces. I will have my office hours Thursday. I have a lot of office hours Thursday, so you might want to try at least part of the lab, watching the video and at least doing the first side. I will also have the Saturday morning. I'm not going to do Friday because I need a day off. And only one person, Oni Dona, came on Friday, so, but it was worth it because she was dressed as a pirate. So, all right, let's go do this. So I'm pretty sure on the test you're only going to have 2 of these to draw, maybe 3, but I did more here because I wanted to review counting valence electrons So I wanted to remind you, you want your periodic table. You guys are going to have things organized. If you did not fix your periodic table to have new group numbers, please make sure you do it. I'm pretty sure you guys did. My other class, some of them office hours, got the mom's voice, and I said, you got to change it. It's got to be numbered with the A group numbers. So the 8As would be the noble gases, 7As, 6As, etc. And then also put your charges there, because we are going to be doing ions. You want, that chart either from your notes or the one that was in the lab that talks about the shapes and stuff. You want it handy. If you did the lab and you do practice, you probably are familiar with it, but have the chart handy or make the chart again. And also the polyatomics. So like I wrote them on here. So you'll want either the polyatomic chart. So make one page that has the molecular geometries and bond angles, has these 8 polyatomics. Don't do all the other ones. And then make up your own little chart about how adding and taking away oxygens. So if you make a page of that, and then the gas laws, just those formulas they're at the top of your worksheet, wherever my worksheet is. Yeah, the ones that are on the board. I would just use those. We're just going to use those. If you use another one, I might take a point off, because I can do that. Squid hat on. I can do anything. All right, let's go ahead and do it. I also wrote these out as names. So oxygen difluoride, because they are molecular. So this is going to be 20 electrons. There'll probably be boxes to fill in on the test, because that actually helps me to see it and grade it. It has to do with how I visualize things too. But when I started doing the boxes, I found students' grades went up, like the average in the class went up 10%, because you guys like the boxes too, because it gives you a clear thing. You can have fun if there's an empty box. All right. Silicon tetrachloride is the 32 electron, which I think it was Shaylee who said, yay, 32. I know what that's going to be. All right, this one, NO2 with a positive. So we have 5 plus 12. And then the positive means we're going to subtract 1. So only 16. So positive, cats have pos, lost an electron. So only 16. Now, if that number is wrong, then your picture is going to be different than mine. All right, the first element given in each one of these will be the center. And oxygen, least electronegative. What's the most electronegative on the periodic table?
Fluorine.
I knew she was going to do it. That was like a test for Tiffany. Yeah, so she was right. It is fluorine. And then oxygen's number 2. So as you're moving towards that corner, they're the greedy ones. They're on the outside. So here's a question. Tiffany, we're going to tape her mouth shut. Can somebody explain to me, Brittany, you can like yell it out loud on there, but you got your bonus point. What is hydrogen hell? There's multiple parts to it, so multiple of you can. Anybody want to describe
electrons around your hydrogens?
Thank you. And yeah, Kristen should get a double point here because she did what I asked. So if you can like put your camera on for a moment, you're gonna get preference, but then I can see who it is. So it is putting dots. Is that what you said? Putting dots on your hydrogen. Hydrogen doesn't get dots. There's more to hydrogen hell. Anybody else?
Double bonds.
Yes. Why, Kaylee?
Because it adds electrons to the hydrogen, and hydrogen doesn't want extra.
Yeah, hydrogen. So, anybody else? There's actually one more part.
Put it in the middle.
Yeah, I have no idea who said that.
Me. Olga.
She's like, me. I'm like, I still don't know who me is. Thank you, Olga. Why does it not go in the middle? So hydrogen doesn't get dots. It only makes a single bond. It never goes in the middle. Why?
It would have to hold more electrons then.
So here, for anybody else, you guys got your point. Somebody else can get bonus point here. Why Why can hydrogen not go in the middle? Why can it not get dots? Why doesn't it do 8? Why doesn't it make a double bond? Anybody? Your periodic table tells you. This is actually going back to the previous celebration. Brittany's like yelling out loud there. It's so great when the orange goes. I'm like, I can just hear Brittany yelling. I know the answer. So its octet, the octet rule is to become like a noble gas. It just needs to become like helium, and it's satisfied, which means the first row did not have p orbitals. So it just needs the s filled, which is 2 electrons. So hydrogen's octet is 2 electrons. All right, so it's never in the center. We put it on the outside, and then we put our dots, and we're done on that one.
Do you not want us to do the clouds?
We're going to. I was going to draw mine first.
I have a question about silicon tetrachloride.
Go ahead.
I counted 34 electrons.
Chlorine times 7 is 28. 7 times 4 is 28, and silicon is 4.
Silicon is, oh, it's
SI, not S. Yeah,
Sorry.
okay.
Thank you for clearing that up.
Yeah, and actually, so if you get more than 32, something's not right. And that would be when you come to Zoom. Don't wait until the last 5 minutes. Come to Zoom like immediately and say, hey, so I'm having trouble counting. So yeah, don't wait, you guys coming on Zoom. If you have a question, just come on. And I am not going to make you like come on when you submit, but I do have a favor to ask. I don't have a problem in this class, but when you submit it, make sure it's there. So, and that I can view it. So I'm having an issue with 2 people in my other class who their pictures I'm having trouble seeing. And so if you're not sure, then you can come on. So like Donna, she knows she's having trouble. So this is the other quick comment. I thought I made it. I don't know what classes I made it in. The iPhone had an update to the app for Blackboard. You have to update it this weekend. And that is why there's been so many issues. So like Shaylee, I'm pretty sure you must have an iPhone because there's been some issues, but make sure it's there.
No, I have a Samsung, but yeah, I've had issues
I don't know
before.
why yours has had, you might have to update the app or something. And then again, you should all be, I think everybody in here has got it where they can scan as one document. So, all right, what's wrong with my last picture? You don't get an answer, Tiffany. Somebody else.
This is Katie, and there's no double bonds.
There is going to be double bonds, but what's wrong? Why do we need double bonds? That's how I should say it. Go ahead,
because
Katie.
Because the nitrogen is not fulfilling the octet rule.
Yeah, this is Katie with a Y, right?
Yes.
So we've used up the 16. So do not make double bonds unless you have to. It's the last resort. So we have the 8 and 8. And so you can look how many double bonds you need. Make sure you put extras on the center. And then we're going to need double bond on each side. So a double and a double. And you can do it like I did it where you cross out your dots, or you can erase if you went and bought yourself a good eraser. All right, now the question Tiffany had asked me, you can circle your clouds. This color is wonderful. Use color. It will make your life so colorful. I have found a lot of you are circling your clouds and you get it right. So just make sure I can see. Somebody's got their, Kaylee, that's you. Kaylee.
That's the big crisis facing the planet. Too much joy sharing. Looks like Boyd is tangled in the hockey net. Oh, you gonna go get him? Oh. I'm gonna get a picture.
Is this you sharing this?
I feel like originally her character would not be the one.
Yay, more parties.
All right.
Well, I would go the best party
I'm gonna mute you. Can I mute her? I have to mute her. Yeah, you can circle them. I do find a lot of students that really helps them. You do not have to circle them, but this is back to question of Donna that you asked, and Tiffany during office hours a week ago. If you like putting numbers like, oh, I have 4 clouds, I don't need those numbers. I just need the answer. This is going to be a tetrahedral. The Vesper is the total clouds and a pyramid. So you do need both answers. Tetrahedral, pyramid, or tetrahedron, pyramidal. I don't care. They're the same thing. And these are about 109 degrees, and it is polar. If you have a lone pair on the center, it is polar. Pyramids are polar. Our next one, 4 clouds, is a tetrahedral bent. Tetrahedrals are all around 109, and it is polar. Bents are polar. There's only one exception to that, and I'm not going to throw that at you.
Did
right,
you want
again,
to find the IMF
clouds.
too?
Yeah, thank you. I will do that. This one, you could just write tetrahedral really big, or you can say it's a tetrahedral. Thank you. 109. So rather than using Google and being extra smart, you pants, just make them all 109. There's like 2 or 3 of you who are giving me really weird bond angles. Like some of you are giving me bond angles I've never ever heard of, and I think it's Google. Google is not going to be our best friend on this. This one is non-polar. They're all the same. They're all chlorines. And then the last one is, if you remember to show your bracket, that might help us when we do the IMFs that Olga mentioned. Thank you. This is linear because there's just 2 clouds. So you can just write linear once, or you can say linear. If there's no lone pairs, you can just write one answer. Linear is 180. There is no such thing as linear bent. If somebody can explain to me what a linear bent is, I would be highly enlightened by that. And if you wrote linear bent, you are not the first student, nor the last. You can't be in a straight line and have a bend. So it's linear or it's a bend. And this is non-polar.
H2O. When we did H2O, wasn't it bent?
It was. This is a tetrahedral bent.
Oh, right. Yeah. Sorry.
I do have a question if anybody thinks they know the answer. There is an exception to bents always being polar. There is one exception I can think of. Anybody know what that is? If you think of it, just come back on. All right. We're going to do the IMF because you're going to have that. And so polar is dipole or dipole. You can just say dipole. This is the IMF in green. This one, we have oxygens, we have fluorines, but there's no hydrogens. So it's just going to be dipole.
Brittany says lone pairs makes it bent and polar.
No, my question was, but she's going to get another bonus point. My question is, there's one time when a bent is nonpolar. All right, this one is nonpolar, so this is London. Nonpolars are London. The last one is not London. So there we go. Why is the last one not London? Somebody knew. It's okay, you didn't unmute yourself. It was on your worksheet. It has a charge. If it has a charge, it is ionic. And on the lab, I emphasize ionic is the top one of the intermolecular forces. We did not have an H bond on here because there was no NOF. Yeah, just wear a really fun NOF. That should be what we do. Yeah, one of the things I talk about in the video is there's a new category. So there's the ionic, then the polar and the nonpolar. And then there's a new category on top, and the one at the bottom, I just didn't know where to put it. But at top is something called a macromolecule, and the whole thing is covalent bonds. So a diamond, like my rose quartz, it is all covalent bonds. There's no IMFs. And so since it's all covalently bonded, it's going to be the highest, like beyond our chart. There's, yeah. All right. Question? My question about the exception, we'll see. Whoever's first one to respond, if anybody ever figures it out. Somebody thinks they got it?
No, I was just gonna say, is the reason NO2 is linear is because of the loss of the electron. Because of NO2 plus, you lose the electron.
Yes, if it's NO2 negative, it ends up bent. Yeah.
Okay.
Yes, that's why this is linear. We never did, I don't think we did these four before. All right. And actually, that's something that reminds me again, don't sit there and try to find the picture that you had like this. Just go back and do parts of the lab again. Maybe do the whole lab. That lab and the naming lab are really good practice. And so, yeah, go back and look at them again, and you're going to do great. It's a celebration of everything you've learned. Go back and do this again. Go back and do your study sets. You have everything you need to do amazing. But notice I keep saying do them again, not have them there and try and ruffle through them and find them and copy answers. That you're not going to get done in 2 hours, and you're not going to do great. So it's doing them again, understanding them, coming to an office hour and saying, hey, can we go over this question? And it'll be great. Yeah, and if you're having trouble with the worksheet, you have to do it tomorrow and come to office hours, and there's a bonus point on there. So, all right, these are both non-polar. Just use pink. But I want the IMF, so non-polar is not the IMF. These are diatomics, they're pulling on themselves. There's no tug of war going on. These are London and London. Something has to win. When they're both London, what do we look at?
Who's the bigger side?
Yeah, who said that?
Huda.
Huda. Only if they're both London. Pick the bigger one. Look at size, meaning on the periodic table. It's actually surface area, so the chlorine wins. All right, the next one. Hooray, this was, you should see that NH, and you're like, oh, H bond. And the other one, it's not an H bond, but we do have different types of elements there, so this is a dipole. Now there was, I can't remember who asked me this question after class the other day, might have been last week, and it was a great question. They said, why was the SiCl4 non-polar? Because just seeing it like this, they saw the SiCl4 and they were thinking, there's two different atoms there. One of them's got to be pooling. When we initially learned the IMFs, that was our rule, but we've expanded past that. It has to do with the whole picture. So if you see silicon with 4 of the same thing around it, that's nothing, it all cancels out. All right, the H bond wins. And then this one, only carbon hydrogen is non-polar, so that is London. And this one, the H's are on the carbon. That was the part of the purpose of that last page of the Lewis Structure Lab. So the oxygen is pooling, but it doesn't have a hydrogen. So that one wins. I did want to ask another question with this. Actually, I want to ask it with number 1. We can do this for bonus. Which one's hydrophobic? You do it. Hydrophobic. Anybody? Number 1? Is anybody there? This one is hydrophobic. The SI, the non-polar, is hydrophobic is the SiCl4. Ones that have polarity, H bonds, polar, they're going to like water. This gets emphasized in that lab. I finally posted the video for today. And it's a short video, Bia, so I wasn't too worried when I forgot. I think it's only like 15 to 20 minutes. So there's a pool and water has a pool. Ionic also loves water. So these three love water. So even though we said it was non-polar, you have to be careful. If it is an ion, it does like water. Ionic and polars like water. And that's one of the things in the video that it talks about. All right, let's finish this page in the interest of time. Vapor pressure is, let's actually walk through them and identify what each one is. So A, resistance to flow, is what?
Solid.
Viscosity. How viscous something is the resistance to flow. These are those properties. All right, so that wasn't our answer. On B, how easily something, the liquid evaporates. Anybody remember what that was? That is the other V word, volatility. Something that's volatile evaporates easily. On C, the temperature that the liquid evaporates. He's like going crazy up there. So fun. So is Tiffany. This is good for them. This is boiling point. So BP, not blood pressure. Boiling point. Keep it in context. I had somebody one time said, why are we talking about blood pressure? We're not in nursing school right now. All right. The number of collisions of gas above a liquid. So when the liquid evaporates, it's called a vapor. That is the vapor pressure, which now when you see that word collisions, you're like, yep, got it. So that is vapor pressure. And then the amount of heat required, anybody? So this is the symbol for it. That is read as delta HVAP or triangle HVAP. Gosh, I thought I wasn't recording for a second, but this is heat of vaporization. This again, so this is your teacher not doing this to be evil. This is your teacher not realizing she did that. That sometimes when I write the test, I use this symbol and sometimes I write the whole thing out. That would be where you come onto Zoom and you don't say, what does that mean? You say, does that mean heat of vaporization? I go, yes. So it's how you word the question is how I can answer. Sometimes I'm like, I can't answer that because that's what I'm testing you on. So if you, in the question showing me, you know, another word for heat. Does anybody know the other word for heat? It's a Greek word. Enthalpy. We get to this at the end of the term. So enthalpy of vaporization is, I think, what I called it in the notes. There was actually one more property, and that was surface tension. So I don't want to leave it out. So if anybody wants to tell me what surface tension
is it the amount of water that can stand on a surface before it flows over the surface?
So that's one of the challenges. So on the lab 6B, there is the surface tension challenges. Is that Bia who answered?
Oh, this is Katie.
Or
with
Katie?
an IE.
Oh, Katie with an IE. So anyway, she'd asked me, there's actually 3 bonuses. There's like a couple bonuses on that lab, and you can get, if you win, you have to take a picture, or my class last year took videos. They were having fun with it. They told me they really love the challenges. Kaylee has an unfair advantage because she probably did these when she was in my kids' class. So, but there is a challenge where you have to fill the glass all the way with water, and then you add pennies. And because of surface tension, the water ends up making like this bubble, and you can add quite a bit of pennies. I was actually amazed how many pennies. You have to be really delicate how you do it. And so very gently, you can add quite a bit. And if you don't have pennies, you can do dimes or nickels or whatever you have. Just if you have pennies, and you probably have plenty of pennies around. So you're on the right track, Katie. I'm just gonna have you refine it.
I don't know. Like, I don't know.
The word attraction, if you use the word attraction in your explanation, does that help? Maybe?
Like,
it's the attraction of the surface for so the surface tension.
like the pull of the molecules in the water to the surface.
Yes, or the surface being pulled, being attracted to the rest of it. And because water has H bonds, it has this high surface tension, and it just doesn't want to spill out. So it's the attraction of those surface molecules. Gives you this tension, and that's why like those bugs can walk. That's why you should be able to float the paper clips. There is a trick to doing it. Your teacher's not very good at it because she's not very patient. It does have to do with patience, but there is other tricks. And I've seen some amazing. All right. So what type evaporates quickly? So evaporating quickly was volatile. And volatile meant weak IMFs. So remember, the weak IMFs evaporated fast. So the volatile and the vapor pressure, these two were the weak IMFs. The other ones were all strong IMFs. So I should have written surface tension with pink. All right. So that would be the weakest one, which is nonpolar. So nonpolar is going to evaporate quickly. All right, so there might be like a multiple choice kind of question. Oh, like on number 3, what was our, it was D, because I asked that. Or it might just be a short answer. If a liquid has, so if it's volatile, it's also going to have a high vapor pressure. So high volatility is high vapor pressure because that's the weak ones. All right, and then we go to number 13. So this question used to be on your study set used to be longer, but because of this environment and the timing. All right, so you have this and you have this. That part doesn't matter. We'll just call them A and B. And we're looking at the vapor pressure is the same, but on this one it's at 150 degrees Celsius, and on this one it's at 57. So for the PBR3, we need a higher temperature. Vapor pressure is evaporating to escape. So vapor pressure is escaping from the liquid to the gas. So if that needs a higher temperature to escape, what do we know? What do we know about the IMFs? Well, you can walk through this. Which one evaporates slower? Well, that one needed a higher temperature. So it must be our first one, the PBR3. It needed a higher temperature, so it's evaporating slower. We had to give it a lot more giggles and jiggles. So which one has the lower boiling point? Really, question C should have been first. Because this one needed the higher temperature, this one has the higher IMFs. So it needed more jiggles to overcome. Temperature, again, is the jiggles and giggles. And I love the essays I get with this, people who take those challenges up. And actually, that was the other question. So that Katie, she didn't ask it, though. She was asking about extra credit. Is it is Healthy November, and so there is still time to do a 30-day challenge. So eating fruits, and you can actually, if you would like, if you picked a 7-day challenge, like to meditate, you can expand it to 30 days and do it for 30 days, and you will write that up at the end of 30. Just keep track when you started, because and if you want to do the jiggles and giggles for 30 days, nobody's ever actually done that. The legumes for 30 days would be phenomenal, or more fruit. You can pick what you're going to do, but it should be more than just drinking more water. So, I mean, you can drink more water, but doing something more with that. And there were some people actually in all my classes who lost, I'm like really amazed, lost 10 pounds in the past month, which was really great, and to keep that up. So, yeah. All right, so the weaker IMF is the PI3, the one that was lower, and so that would be the same for the lower boiling point, would be the weaker one. This is actually a really good page, as is your study set. So going back and doing it, are there any questions with that page? I have to put Katie's name up here. All right. So, do you guys want a 5-minute break to try it? Or you want to just go for it? I mean, stop, give you guys 5 minutes, or you take a break, or you can sign off. Be drinking.
Mushrooms were hard on your liver. Weird.
They can be. Anyway, this is my card. I love this lady, the artist. I'm not gonna remember her name, but anyway, I like this one too. This is the unicorn. Gratitude and appreciation. They're all my favorite card, but I thought I would share that. I lost the page that we were working on. There we go. So that's what I'm staring at while we're in class.
Is that a tarot card?
They are, it's a type of fairy card. So yeah, it's not the tarot deck, but if you ask me or send me an email, I can tell you what the name of those were. She's like one of my favorite artists. She does a lot of magical things. I'm recording this, so and they're really fun. They're really beautiful pictures. All right. So have this on your periodic table, and if it's possible, it will be there on the page, so it's right there staring at you, because that's helpful. Let's do this question though first. Which ones are molecules? So not 1, 2, 3, 4 is a molecule because it's non-metals. So molecules again are 2 or more non-metals. And also the acids are molecular. So we're just going through 1 through 8. So that was in the study set. So again, study set 6, 7, 8, 9, and 10. The study sets especially, and then, you know, going also looking at your notes in this review and the worksheets and the labs are good practice. So you each know what you need extra practice at, but at least redoing all of those study sets. All right. The molecules, I mentioned that because it can be, this is covalent. You're going to name this one with the penta. So it's the first one gets its name, and then the second one changes the ending always. So the first element, we always say its normal name, iodine, and you're telling me how many are in there. The other ones, you do not use dis or tris or tetras or pentas. All right, the acids are molecular, but we think of them as ionic for naming, even though they're not. All right, now my next question, which actually, let's go ahead and do the acids. So this was nitrate. So the nitrate becomes nitric IC acid. And then this, so when you see the ClO3, just add next to it the family, BrO3 and IO3. So that whole family in the periodic table Oh wait, I was supposed to change out of my, I don't know where my cat ears are. Right, we're doing the cation. All right. So same family, chlorine, bromine, iodine, all make the same polyatomic. This is IO4. So like the cat, we per. So this is per, it'd be periodic or periodic acid. So we show the hydrogen first. So you can put a parentheses, it's the IO4 and the NO3. All right, my question for you, which of the ones that are left need a Roman numeral?
1, 3, and 7.
1, 3, and 7. Who said that?
Tatum.
Oh, thank you. Yeah, I'm like, I know that voice, but your teacher's getting tired like all of you are. Yeah, and she knows that because it's the ones that do not, right? So the 1As and the 2As, Tatum's like the master of this. She like impressed me extremely. So the 1As and 2As and aluminum, no Roman numerals. So like this one, we just say sodium, but the iron, and this is why becoming familiar, you can have names on your periodic table, but hopefully you're becoming more and more familiar, where the CR is chromium. They're going to get parentheses. To figure out the number in the parentheses, we look at the second part. So if it's not one of the polyatomics, IDE. So I'm looking at the ending of your name, and we look at Cl on the periodic table. Again, go ahead and label your periodic table beforehand. So all that stuff is ready. Come in ready to go. Do this review again and pretend like this is the celebration. So Tiffany, this is great advice for you, is sit down, and for all of you, pretend this is your celebration, print it again, or print it out again, blah, and see how long it takes you. I mean, do it calmly and say, hey, yeah, it really wasn't that bad. And probably will take you longer because you're still in the studying mode, and this is longer than the test, especially the gas law page. So, and even me going through it. So the chlorine is -1, so the iron must be a +2. Sodium, no Roman numeral, because the first two columns, no Roman numeral. And with this, you want to look at the PO4, and you look over here and you say, yes, it's PO4. So you can add your parentheses. All right, NO2, we look over here and it's NO3. So it becomes a nitrite. We lost an oxygen. We look at nitrite, NO3, it's -1. So this is still a -1. There's 3 of them. So the nitrite is because in the parentheses, there's 2 oxygens. So it's chromium 3. It's going to be a +3. All right, sodium again. And you're not going to do sodium chlorine oxide. There's always 2 words. So put a parentheses. And the ClO is where we go here. If you take away 1 oxygen, that's when we do the ites. If you take away 2 oxygens, that's when you do your hypoite. So make yourself a simplified chart. Like mine had too much examples on it, but you just need that. If you add an oxygen to what we have up here, you would have a per and the 8. So we have our starting point, which are those. So this is where we took 2 away and we go to hypochlorite. This is bleach. It looks funky. It looks like it should be reacting. That's what we're moving to. So I'll be videotaping this weekend the lecture that I would normally have done Monday. So for your study set and stuff for Wednesday. Next week's a big week. Yeah, it'll be fine. That's me talking to myself. I gotta go in and try and do demos again, and they're gonna work. All right, S is a -2. So this is where they switch. So, right, the 3 must have been on the vanadium. So we say vanadium 3, and it ends with just the IDE. And it is pretty close to 8 o'clock, so if you have to sign off, I will upload this, or you can stay. All right, for these, it may have like on your worksheet and your lab where you had columns of ions, but we're going to go ahead and write the ions. Titanium, this means titanium has a 2 charge. Oxide just means just oxygen, so it's just TiO, 1 of each. Gold has a 3 charge. Chlorite, like underlining that ending. It is ClO2 with a -1. And I did notice a lot of you used the parentheses as you were writing your ions, and that was really helpful. Yeah, you all did actually really well on that lab. So going back and practicing. All right, calcium is +2. Hydroxide, so just a reminder, these last 3. Hydroxide is just OH. You can write it as HO. Bicarbonate is that special one. It's actually really common. Bicarb in hospitals and stuff is what they call it. So OH, so we'd get CaOH and then a subscript 2. So make sure you keep them as subscripts. A lot of you know that yours started floating up, so make sure you keep it as a subscript. This prefix hydro means there's no oxygen in the acid, so it's just HI. This is high. There's no oxygen, so it's the iode, which is iodine. All right, Mn with a +2, Br with a -1. So, you know what you can also do is go back, pick one day to do study for each part of the test. So one day say, okay, I'm going to go back and review ions and naming. Next day, so even though there were 5 study sets, really the ions and naming went together. And then one day I'm going to practice doing the liquids and the Lewis structures. And those labs, if you all did those labs, then you've got it down. And if you didn't do the labs or you didn't do great on the lab, just take the time to come to an office hour and we'll walk through it. All right, the Thursday afternoon office hour is still there. Yeah. All right, sulfite is, we go to sulfate. It was SO4, so this is SO3. And it's the same charge as sulfate was. So it's still a -2, so 2 and 3 switch, so 2 aluminums and 3 sulfites. All right, OUS, so that's the other thing. The 8s for the acids become IC, and the ites were the OUS, so that's for the acids. So again, make yourself a simplified thing that you understand. You don't want a lot. All right, so this would be, we look up PO4 is phosphate, so this would be phosphite, so it's PO3 with a -3. Hydrogens are a +1, so H3, PO3. All right, and then the last one is sodium, and then bicarbonate, this all goes together, HCO3. So it's just Na and then HCO3. If you use parentheses, you would put it around the HCO3. Technically, this one doesn't have parentheses, but I don't care if you use parentheses. All right, X has 2 valence. You guys remember this in the homework? When you first saw it, you're like, what is she asking? X has 2 valence, so that would be a 2A +2. Z has 5 valence, so Z is going to be -3. It's going to be like this family, that is the 5s. That's why I have you renumbering your periodic table, and they're -3. So then we just combine them and we keep it how it was. This is the 3:2 ratio. All right, calcium ion. So calcium is Ca, so 20 protons. And it used to be on the last midterm, we had 20 electrons, but it is now an ion. So when calcium makes an ion, it's a +2. Now, I want to remind you, we get overconfident and we remember, a lot of people mix things up in their head. Make sure you look at your periodic table. If calcium is a +2, that means it lost 2 electrons. So it is now 18 electrons. Makes sense, it's like a noble gas. All right, which ones come out the same as neon? So sodium, it would lose 1. Not potassium, not titanium. Sulfur would be here, it would move towards argon. So the only one was sodium. All right, any questions? So gas laws. Let's just do it. Again, I'm just going to walk through the setups for these. Make your list. So you have your 755 millimeters of mercury. You have your volume. I don't know that I'm going to go through all of these. So you have your P1, your V1, and then you have a new pressure. I've spent a lot of time going through the study set. So, and it wants new volume. So make your list, write your formula. It's telling us it's this. And then we plug in. My answers are here for each of these. And so I'd rather have you guys go through it, but I do want to go through B on this one. So if we look, we increase the pressure. So what should happen to the volume and why? So pressure goes up, volume should drop. These two always go opposite. And so there's more collision because there's less space. More collisions because less space. All right. Yeah, the next one, I wanted to remind you, you're going to be doing, you're going to have to flip it over. And so you might not want to write that down because that way you can try it yourself. But if you're solving for temperature, temperature has to be on top and it must be in Kelvin. That is actually usually the most missed thing on the test. I asked for it in Celsius, but gas laws cannot be solved in Celsius. You do it in Kelvin, and then you can go backwards to Celsius. If it's asking what's the density, what formula would we use? Density is the PM equals DRT. Yeah. So we're going to use D, and just a reminder, STP, that's where that gives you a temperature 0 Celsius and 1 ATM. So it's giving you a temperature and pressure. The other thing I want to remind you on this one, we may have done this one in the notes. It gives you chlorine. This is not a noble gas. This is Cl2. So remember the diatomics. I talked about them the other day and again today. The gases, they are 2 exception, the noble gases, because they're already perfect. So they would always only have 1. So perfect. Give me a cap. All right. And then the next one, I don't see lots of different numbers. I'm only seeing 1 volume, 1 temperature. The mass, you're going to have to change to N. It is not N. You're going to have to change it to N, to moles. This is my volume. This is my temperature. So this is a PV equals nRT. So back to the question Tiffany had asked and other people during office hours, that is really the key, is figuring out which piece. And the other part is that mole. So it's back to the question, Again, from the previous exam, we run into moles. We keep running into it. Go ahead, Tiffany.
Is the R always going to be that 0.0821?
Yeah. Yes. For what we're doing, you guys are going to use my R, which is the 0.0821 ATM liter per mole K. And I wouldn't make yourself like on your, just have one page of your things, put those up there, put those on there. And you can even put a note when you're going to use it. But if you do the practice, it should now be much smoother. Most students do really good with the gas laws. But again, they come in with a lot of chaos into the study set. And then by the time they leave today, everybody's feeling better. Number 5. Oh, and yeah, you're going to solve. P is going to be in ATMs. And then you would go back to TOR. So you guys know, you can figure that out. That would be one little factor label step. Make sure you show your work nice and orderly. So if it's all over, so practice that as you're doing it. And if that means you have to put it on another piece of paper, just put a note, it's on another piece of paper. But on the test, I will give you definitely more room than I did on here. This has more practice than you would see on the test. This one is, we have a mixture. So we have nitrogen plus oxygen plus helium. So again, these two are diatomics, helium's not. And the total is 760 torr. The nitrogen is just 120 torr. The oxygen is 240 torr. These guys just add up. And the helium is my unknown that I'm solving for. And so we would just rearrange and solve. So it looks like the answer is 400. So that's, yeah, pressures add up. All right. Number 6, we did this in the homework. This is asking, we're trying to decrease the temperature. So if we increase the pressure, pressure will increase temperature. So that doesn't work. Density, that's the PM equals DRT. So PM equals DRT. Density and temperature are going to be opposite. So if you decrease density, temperature will go up. So that doesn't work. Molecules would be looking at N. So that's P equals nRT. So again, they're on the same side. If one goes down, the other goes up. So that doesn't work. And volume. They're on opposite sides. So none of them worked. If you increase the volume, temperature goes up. If you decrease the molecules, temperature goes up. If you decrease, yeah, that's fun. That would drive you all crazy if that happened on the test. And I hope if that happened, you know, sit there and frustrate and just go, I have that crazy lady who dresses up as everything in class who probably, it could happen. So don't lose sleep over it. Just be like, it's a question. I'll get part credit because I know. But yeah, it came out none of them. I wonder what the question originally was. Maybe there was a choice E that said none of the above on a test. Wow. All right. I wanted to go over 7 because I thought it was in the homework and it wasn't. And so I put it on this. You have to rearrange it to get it back like how we had it up there. So you have to move the ones to the same side. So like here, I have to move my P up because it's on the bottom. So I end up with P1V1 equals P2V2. So you have to move the ones to one side and the twos to the other side. And then you look at it and you go, oh yeah, that's good. Pressure times volume equals pressure times volume. So that one's okay. Then here, when we move it, we would divide by the T's. So you end up with B1 over T1. And I know I'm going kind of fast because it's late. And I know some people have questions on the worksheet while your teacher's still awake. So again, move the ones to one side and then say, yeah, that's the same. Volume over temperature equals volume over temperature. On this one, we gotta move the P1 down there. So T1 over P1 equals T2 over P2. And yeah, that would work if we flip it. The T and the P are on different levels. So that one's okay. So then the last one, we'd have to move our P2 down there and you end up with V2 over P2 equals V1 over P1. And again, you can go back and rewatch the video, watch this part, and then come to my office hour tomorrow, or yeah. That's definitely wrong. That gets a big frowny face. We want pressure times volume, so not pressure over volume. So that's just like wrong. Any questions before I stop? And thank you. You guys are amazing. You're all amazing. I hope you have fun with the labs. I'll be on Saturday morning, tomorrow, lots of time. And then the weather gets really nice Sunday. And actually,